Yes, there are specific requirements when running a standard voice grade phone line to an alarm dialer 800 feet away in 2-inch conduit. The recommended wire to use is Cat5e or Cat6 twisted pair cable. These cables provide superior signal quality and are commonly used for telephone and data transmission. AWG or American wire gauge measures the thickness of the copper wire. For an 800-foot run, you will need 24 AWG or 26 AWG wire. 24 AWG is recommended for better signal strength over longer distances. Solid core wire is preferred for long runs as it is less prone to signal loss due to bending. Use shielded twisted pair or SDP cable if there is potential for electromagnetic interference or EMI. Include a pull string in the conduit for easier future replacement or maintenance. Make sure the conduit is not overfilled with cables. The maximum fill capacity is typically 40%. Always follow the manufacturer's instructions and local built-in codes for proper installation. It is recommended to consult with a qualified electrician or network technician for professional advice and assistance. Now let's delve into each of these aspects in greater detail, providing a comprehensive understanding of the considerations involved in running a phone line over a long distance. Firstly, the selection of the appropriate wire type is crucial for ensuring reliable signal transmission. Cat5e and Cat6 cables are the preferred choices due to their superior signal quality and widespread use in both telephone and data communication systems. These cables are designed to minimize signal loss and interference, which is particularly important when dealing with longer cable runs. Secondly, the American wire gauge, or AUG, plays a significant role in determining the wire's current carrying capacity and its ability to transmit signals effectively over a given distance. For an 800-foot run, it is recommended to use either 24 AWG or 26 AWG wire. However, 24 AWG is generally preferred as it offers better signal strength and lower resistance, which helps to maintain signal integrity over longer distances. Thirdly, the type of wire core can also impact signal quality and reliability. Solid core wire is generally preferred for long runs because it is less prone to signal loss due to bending or flexing. This is because solid core wires have a single, continuous strand of copper, which provides a more consistent and uninterrupted signal path compared to stranded wires. Fourthly, electromagnetic interference, or EMI, can be a major concern when running cables in environments with electrical noise or other sources of interference. In such cases, it is advisable to use shielded twisted pair, or SCP cable, which provides an additional layer of protection against EMI. SDP cables have a metallic shield that surrounds the twisted pairs of wires, which helps to block out external interference and maintain signal integrity. Fifthly, including a pull string in the conduit during installation can greatly simplify future maintenance and replacement tasks. The pull string can be used to easily pull new cables through the conduit without having to remove the existing ones, saving time and effort. Sixthly, it is important to ensure that the conduit is not overfilled with cables, as this can restrict airflow and potentially lead to overheating. The maximum fill capacity for conduits is typically 40%, which means that the total cross-sectional area of the cables inside the conduit should not exceed 40% of the conduit's total cross-sectional area. Seventhly, always adhere to the manufacturer's instructions and local building codes when installing telephone wiring. These guidelines provide important information on proper installation techniques, safety precautions, and code compliance, which can help to ensure a safe and reliable installation. Finally, it is always recommended to consult with a qualified electrician or network technician for professional advice and assistance, especially when dealing with complex wiring projects or unfamiliar environments. These professionals have the knowledge, skills, and experience necessary to ensure that the installation is done correctly and safely. In addition to these specific recommendations, there are also some general best practices that should be followed when running telephone wiring. Firstly, always use high-quality cables and connectors to ensure reliable signal transmission and minimize signal loss. Secondly, avoid running telephone cables near sources of electrical noise or interference, such as power lines or fluorescent lights. Thirdly, properly terminate all cable ends with appropriate connectors, ensuring that the connections are secure and reliable. Fourthly, test the wiring after installation to verify that it is functioning correctly and that there are no shorts or open circuits. Fifthly, label all cables and connections clearly to facilitate future troubleshooting and maintenance. Sixthly, document the wiring layout and configuration for future reference. Seventhly, keep the wiring neat and organized to prevent tangling and damage. Finally, regularly inspect the wiring for signs of wear or damage and replace any damaged components promptly. By following these recommendations and best practices, you can ensure that your telephone wiring installation is safe, reliable, and compliant with all applicable codes and standards. Remember that proper planning, careful execution, and attention to detail are essential for a successful wiring project. Always prioritize safety and consult with qualified professionals when necessary to ensure that the installation is done correctly and safely. Now let's expand on each of these points with additional details and explanations. When selecting Cat5 or Cat6 cables, consider the specific requirements of your application. Cat5 cables are suitable for most standard voice and data applications, while Cat6 cables offer higher bandwidth and improved performance for more demanding applications. Choose the cable that best meets your current and future needs. When determining the appropriate AWG for your wiring, consider the length of the cable run and the amount of current that will be carried. Longer cable runs require thicker wires to minimize signal loss and voltage drop. Consult an electrician or a wiring chart to determine the correct AWG for your specific application. When using solid core wire, be careful not to bend it excessively, as this can damage the wire and cause signal loss. Use appropriate bending tools and techniques to avoid damaging the wire. When using shielded twisted pair or STP cable, make sure to properly ground the shield to provide effective protection against electromagnetic interference or EMI. Follow the manufacturer's instructions for grounding the shield. When installing a pull string in the conduit, make sure that it is strong enough to withstand the weight of the cables that will be pulled through it. Use a durable pull string made of nylon or polyester. When filling the conduit with cables, leave enough space for air circulation to prevent overheating. Do not exceed the maximum fill capacity specified by the manufacturer or the local electrical code. When following manufacturer's instructions and local building codes, pay close attention to the requirements for grounding, bonding, and overcurrent protection. These requirements are designed to ensure the safety of the installation and prevent electrical hazards. When consulting with a qualified electrician or network technician, be prepared to provide them with detailed information about your application, including the length of the cable run, the type of equipment being connected, and any potential sources of interference. This information will help them to provide you with the best possible advice and assistance. In addition to these specific considerations, there are also some general tips that can help you to improve the performance and reliability of your telephone wiring. Firstly, use high-quality connectors and termination tools to ensure secure and reliable connections. Secondly, avoid splicing or joining cables whenever possible, as this can introduce signal loss and interference. Thirdly, protect cables from physical damage by routing them away from sharp edges, heavy objects, and other potential hazards. Fourthly, use cable ties or other organizing tools to keep cables neat and tidy. Fifthly, test the wiring regularly to identify and correct any problems before they cause a major outage. By following these tips, you can ensure that your telephone wiring provides years of reliable service. Remember that proper installation and maintenance are essential for a safe and efficient wiring system. Always prioritize safety and consult with qualified professionals when necessary. It is also important to understand the basic principles of telephone wiring. Telephone wiring typically consists of two or more copper wires that are twisted together to form a twisted pair. The twisted pairs are used to transmit voice and data signals between telephones, modems, and other communication devices. The most common type of telephone wiring is unshielded twisted pair or UTP cable, which is used in most residential and commercial telephone installations. UTP cable consists of 4 twisted pairs of wires, which are typically color-coded for easy identification. The color codes are typically blue, orange, green, and brown, with each pair consisting of a solid colored wire and a white wire with a colored stripe. Telephone wiring is typically run in a star configuration, with each telephone or device connected to a central distribution point. The distribution point is typically a telephone junction box or a patch panel, which allows for easy connection and disconnection of telephone lines. Telephone wiring must be properly grounded to prevent electrical shock and to minimize interference. The grounding wire is typically a green or green and yellow wire that is connected to a metal water pipe or a grounding rod. Telephone wiring must also be protected from overcurrents, which can damage the wiring and equipment. Overcurrent protection is typically provided by a fuse or a circuit breaker. Telephone wiring must comply with all applicable codes and standards, including the National Electrical Code or NEC and local building codes. These codes and standards specify the requirements for the installation, grounding, and overcurrent protection of telephone wiring. Failure to comply with these codes and standards can result in fines, penalties, and even legal action. It is important to consult with a qualified electrician or network technician to ensure that your telephone wiring installation complies with all applicable codes and standards. A properly installed and maintained telephone wiring system can provide years of reliable service. However, a poorly installed or maintained system can cause problems such as poor voice quality, dropped calls, and even electrical hazards. Therefore, it is important to take the time to plan your telephone wiring installation carefully and to follow all applicable codes and standards. By doing so, you can ensure that your telephone wiring system is safe, reliable, and efficient. Now, let's consider the specific case of running a telephone line to an alarm dialer. An alarm dialer is a device that automatically dials a telephone number when an alarm is triggered. Alarm dialers are commonly used in security systems to notify the police or a monitoring service in the event of a burglary, fire, or other emergency. When running a telephone line to an alarm dialer, it is important to ensure that the wiring is reliable and secure. The alarm dialer must be able to reliably dial the telephone number in the event of an emergency, and the wiring must be protected from tampering or damage. It is also important to ensure that the telephone line is dedicated to the alarm dialer and is not used for other purposes. This will prevent the alarm dialer from being interfered with or disconnected. When running a telephone line to an alarm dialer, it is recommended to use a dedicated telephone line that is not used for other purposes. This will ensure that the alarm dialer is always available to dial the telephone number in the event of an emergency. It is also recommended to use a high-quality telephone cable that is specifically designed for alarm systems. These cables are typically shielded to protect against interference and are designed to withstand the rigors of outdoor use. When installing the telephone cable, it is important to protect it from physical damage by routing it away from sharp edges, heavy objects, and other potential hazards. It is also important to secure the cable to prevent it from being pulled or damaged. When connecting the telephone cable to the alarm dialer, it is important to follow the manufacturer's instructions carefully. The connections must be secure and reliable to ensure that the alarm dialer can reliably dial the telephone number in the event of an emergency. It is also important to test the alarm dialer regularly to ensure that it is functioning properly. The alarm dialer should be tested at least once a month to verify that it can dial the telephone number and that the connection is clear and reliable. If the alarm dialer fails to dial the telephone number or if the connection is poor, the wiring or the alarm dialer itself may need to be repaired or replaced. By following these recommendations, you can ensure that your alarm dialer is reliable and secure and that it will function properly in the event of an emergency. Remember that proper installation and maintenance are essential for a safe and efficient alarm system. Always prioritize safety and consult with qualified professionals when necessary. Furthermore, consider the environment in which the telephone wire will be installed. If the wire will be exposed to extreme temperatures, moisture, or chemicals, it is important to use a cable that is specifically designed for those conditions. Outdoor cables are typically made of weather-resistant materials that can withstand the rigors of outdoor use. Cables that are used in damp or wet environments should be waterproof to prevent corrosion and electrical hazards. Cables that are used in areas where there are chemicals or other corrosive substances should be made of materials that are resistant to those substances. It is also important to consider the potential for vandalism or tampering. If the telephone wire will be accessible to the public, it is important to protect it from vandalism and tampering. This can be done by routing the wire in a secure location, such as inside a conduit or behind a lock panel. It is also important to use tamper-resistant connectors and hardware to prevent unauthorized access to the wiring. When choosing a telephone wire, it is important to consider the impedance of the wire. Impedance is a measure of the opposition to the flow of electrical current in a circuit. Telephone wires typically have an impedance of 600 ohms. It is important to use a telephone wire with the correct impedance to ensure that the signal is transmitted properly. If the impedance of the wire is not matched to the impedance of the equipment, the signal may be distorted or lost. It is also important to consider the capacitance of the wire. Capacitance is a measure of the ability of a circuit to store electrical energy. Telephone wires typically have a capacitance of about 10 picofarads per foot. It is important to use a telephone wire with the correct capacitance to ensure that the signal is transmitted properly. If the capacitance of the wire is too high, the signal may be attenuated or distorted. When installing telephone wiring, it is important to avoid sharp bends in the wire. Sharp bends can damage the wire and cause signal loss. It is also important to avoid running the wire near sources of electrical noise, such as power lines or fluorescent lights. Electrical noise can interfere with the telephone signal and cause poor voice quality. When connecting telephone wires, it is important to use the correct connectors. The connectors must be properly crimped to ensure a secure and reliable connection. It is also important to use a connector that is compatible with the type of wire being used. There are different types of connectors for solid wire and stranded wire. After the telephone wiring has been installed, it is important to test it to ensure that it is working properly. The wiring can be tested with a telephone line tester. A telephone line tester can be used to check the voltage, current, and impedance of the line. It can also be used to check for shorts and opens in the wiring. If the telephone wiring is not working properly, it may need to be repaired or replaced. It is important to consult with a qualified electrician or network technician to diagnose and repair any problems with the wiring. A properly installed and maintained telephone wiring system can provide years of reliable service. However, a poorly installed or maintained system can cause problems such as poor voice quality, dropped calls, and even electrical hazards. Therefore, it is important to take the time to plan your telephone wiring installation carefully and to follow all applicable codes and standards.